as we get started here, I just wanted to kind of say I think this is really fitting. We are a week away from the start of the actual monsoon season here on June 15th, but we're actually in a unique pattern right now where we're going to get a kind of a monsoon preview or taste of the monsoon starting later this evening for folks that live across southern Arizona, and then tomorrow across all of south central Arizona and even central Arizona, and we could see some blowing dust and storms. So it is kind of fitting when we talk about this. Mother Nature is complying, and it'll be fresh in your minds. So let's start off with just some quick basic information. When is the monsoon? As I mentioned before, the season officially starts on June 15th. It ends on September 30th. But as many of you or all of you that live around the desert area here know, that the actual onset, when we actually get enough moisture for storms across the higher terrain and even in the lower deserts, usually comes around July 7th for the Phoenix area. And a typical end is usually in the first week in September. So it's also worth noting that every year, the onset and end dates, they can be earlier by a few weeks or even later by a few weeks, and also depending on what part of the state you're in. So that kind of all comes back to why we've just created this official season range from June 15th to September 30th, just to kind of get everybody on the same page. So as far as rainfall stats here in Phoenix and at the Phoenix Sky Harbor Airport, your average season rainfall is just under 3 inches, about 2.71, and that makes up about 30 to 40% of the yearly total. Wettest season, just above 9.5 inches, back before driest season, just over a quarter of inch, way back in 1924. And then on any given season, we're looking at about 11 days with rain at the airport, and that's just looking back since 2000. As far as last year, we had 3.29 inches of rain, and ultimately it was reported as a wet monsoon season. But I guess that kind of depends on your perspective. So that value, again, is coming at the airport. But if we take a little bit more complete look around the county, what you're seeing here are rainfall totals for the 2015 monsoon season from all of our alert rain gauges, and you can see those highlighted in black. As far as the color coding, the greens denote lower totals, and then as you move into the yellows, oranges, and reds, and you go into higher totals. And I just wanted to kind of point out here, our two main areas in these polygons, these are the areas where rain gauges receive 3 inches or more of rain, which is the average what we get when we take all rain gauges combined during a monsoon season. And as you notice on here, the airport happens to be in one of the favorite spots along with parts of South Phoenix and maybe even Tempe and a little bit of Chandler. And of course, we had our significant rain event on the 18th of July up in the Wickenburg area. But for anybody else, last year was kind of a really bad season in terms of rainfall. Much of the county and much of the Phoenix urban corridor was below average to well below average. So in terms of your perspective, yes, it was wet at the airport, but it was really dry as a whole. If we kind of look at all of the gauges averaged, again, our mean total, which we typically see, is around 3 inches. You can see 2015 on the far right here. We actually only got just over 2 inches, or about 72% of normal for the entire county. So with that, let's move into this year. So here you're looking at the Climate Prediction Center's 3-month outlook for this upcoming summer, and that would be July, August, and September. And these are 3-class forecasts. And so what that means is they're giving probabilities of above average, or excuse me, above normal, normal, or below normal temperature and precipitation. So as far as temperature, CPC is calling for a 57% chance for above normal temperatures, 12% for below, and 31% being around normal. So favoring this warmer than average summer season. In terms of rainfall, unfortunately, we're getting these equal chances for above, below, or normal, and that's something that's kind of typical during the monsoon season, just because larger scale features are much harder, or don't necessarily come into play as much as smaller scale features of the monsoon season. So trying to make a prediction this far out and for an entire 3-month period isn't usually as relevant. But what we're going to try and do is kind of delve into some of the main features that we might typically see, and see if we can pull out some more information from that to try and gauge where we're going to be. So before we do that, I want to just do a quick refresher on the North American monsoon in general, And basically, all the monsoon is it's a shift in the wind pattern. So typically what we see during the fall, winter, and spring are generally westerly flow, so west to east or northwest to southeast. Now as we transition into the late spring and summer, flow tends to move more out of the southerly or southeasterly direction. The main mechanism behind that, so we call our monsoon ridge, and during the month of June into early July, the monsoon ridge progresses north into the desert southwest and promotes southeasterly flow at mid and upper levels. So we're getting moisture pulled in from Mexico and even the Gulf of Mexico. And then intense heating across the Mojave Desert and Sonoran Desert also lends to a thermal heat low, which can help pull moisture north out of the Gulf of California and even the Pacific. And as soon as we reach the right amount of moisture, we start to get daily thunderstorm chances across the higher terrain. And if we're lucky enough, we may even get thunderstorms down on the lower deserts and in the valleys if we have triggering mechanisms. So let's start off here with El Nino because it's everybody's favorite topic. We just experienced one of the strongest El Ninos on record this past winter, and it's actually significantly weakened up to this point in the spring. In fact, I just got an email this morning from NCEP CPC saying that we are officially no longer in El Nino conditions and we have moved into end zone neutral. And so if you look at the diagram on the top right, you're looking at sea surface temperatures across the equatorial Pacific, and you can see we go from above average sea surface temperatures and then trending towards these cooler temperatures across that equatorial Pacific, which is more of a signal towards neutral and possibly even moving into La Nina conditions. And as we look at the image below, the probabilistic forecast, CPC is also basically stating that we are moving into neutral conditions, and we're there now, and potentially trending towards La Nina, which becomes the favored signal as we move into late summer, fall, and into the upcoming winter. And so overall, the El Nino climate signal isn't a huge strong factor, especially in terms of rainfall or even temperature so much during the monsoon season, but it does have an effect. And so I want to try and kind of help show this here. And what we're looking at are box and whisker plots showing precipitation during the July, August, and September period for Climate Division 96. And if you look in the top left, Climate Division 96 here makes up all of Maricopa County, basically south central Arizona, parts of central Arizona, and southwest Arizona. And so to kind of understand these plots here, we have precipitation across the y-axis, and then we have the conditions. So are we in El Nino, neutral, or La Nina conditions for that particular year? And what we have here, again, is our box and whisker plot. The red line denotes the 50th percentile. So half of the years fall below that line, and half of the years fall above that line. That's basically our average, given a particular event, whether it's El Nino, neutral, or La Nina. If we go to the edges of this blue box here, what you're looking at on the bottom is the 33rd percentile and the 67th percentile. So for this bottom one, 33% of the events all fall below the bottom of that box, and above this one here, 33% of the events actually lie above that. And then as we move out into the whiskers, we get to the 10th and 90th percentiles. Long story short on here, basically any of the seasons that fall within this middle box are basically around normal conditions in terms of rainfall. As we extend up into the the whiskers on either side of the plot, you get to below normal, which would be below the box, or above normal above the box. And then if you extend past the whisker, you get into those much above normal to record wettest or much below normal to record driest. And ultimately, these distributions are fairly similar. What we're seeing is on end zone neutral and La Nina years, the slight tendency towards more variability and slightly wetter conditions. And then with El Nino, a little less variability and slightly drier conditions. But overall, the signal's not very strong, and we've kind of emphasized this the last couple of years. And but what I would like to do now is focus in on the monsoon ridge itself, kind of the main catalyst that drives the monsoon here. And so what you're looking at is I'm going to show a series of 500 millibar height images, and monsoon ridge gets denoted in those areas with the higher heights. So if we look kind of in the center here, this red area of higher heights represents the monsoon high. So I've gone back and looked since 1980 at a bunch of the different years, and what you're looking at here is neutral years. So Again, no El Nino, no La Nina, kind of normal conditions. And we can see the general placement of the monsoon high happens to be right around the Arizona-New Mexico border. And that's actually lending to southeasterly, southerly flow at mid and upper levels. And this is actually more of a favorable pattern, at least in terms of setting up the large-scale atmosphere for getting thunderstorms. Now, if we want to switch to what we experienced last year in 2015 with the developing strong El Nino, as well as what we saw back in 97 and in 1982, so our three strongest El Nino patterns over the last 20 years, excuse me, more than that, 30 years, we can ridge has actually been shifted further to the south and to the east, with the center being more along the Texas-New Mexico border. And why that's kind of important is the large-scale pattern, this kind of favors more southwesterly mid and upper level flow, a little less conducive for seeing storms, or at least the pattern for seeing storms across the lower deserts. And as you can remember, there weren't all that many storm days last year. This is also important too, because the strength of the ridge, the stronger the ridge, the better chances for warmer temperatures. So what I want to do now is go into what would be a transition, so kind of what we're expecting to experience heading into this monsoon season. And what you're looking at is July through August of 1983 as well as 98, so after the last two big events. And we can see that that ridge center has actually shifted farther to the north and actually extends out into the southern plains. And this is a pattern that, again, is more favorable for having this southeasterly to southerly flow across Arizona. And this actually kind of comes in line to one of our classic large-scale setups in terms of seeing severe weather and extra rainfall type days across Arizona as a whole. I want to note that even though you're seeing these composites of where the monsoon ridge is for that July and August period, it shifts around all the time. It doesn't stay in the same place. The ridge may shift across the Great Basin. It may sink farther south into Texas or in the southern plains. It moves around. But ultimately, what we'd like to see is this ridge somewhere near the Four Corners or southern plains area as a whole over that period to have a good shot at maybe seeing a wetter season or having favorable conditions for storms. And we can see, again, that 2015, our last year, and these strong El Nino years with having the ridge shunted further to the south, it's a little less favorable. I will note that this can make for a very volatile combination, especially as you head into September when we reach peak hurricane season, as well as when we start to get cutoff lows in the area. Having that low shifted, or excuse me, the high pressure area shifted further south can help pull moisture in from tropical systems or allow these upper level disturbances to move across the area, and we can get some pretty significant rain events like what we saw even back in 2014. So, but during July and August, this isn't what we typically like to see. So, we're now moving on here to sea surface temperature anomalies across the entire globe. And there's a few features on here I'd like to point out. First, you can see across the equatorial Pacific our weakening El Nino transitioning towards neutral / La Nina conditions. And also, we still have this signal of a positive Pacific decadal oscillation. So you're seeing a cold pool of water across the North Pacific, and you're seeing warmer than average sea surface temperatures from the Alaska coastline down into the Northern America. And why I kind of wanted to bring this up is looking at previous research done after the North American Monsoon Experiment and some of the work even before then, that cold pool tends to favor the establishment of the ridge across the Great Plains during the summer season, higher heights. And when we have that, we typically tend to see our wetter seasons across the desert Southwest. Not always a guarantee, but it's a good sign. So now I want to kind of focus in on the Gulf of California right here. We can see the southern half of Gulf of California. We're seeing warmer than average sea surface temperatures and then near normal temperatures as you move into the northern part of the Gulf. And so I can pull up the actual sea surface temperatures as of the end of May, and we can see this cooler temperatures farther north with these warmer waters farther to the south. And the reason I bring it up is that a lot of the research has shown is that actually 80% of the rainfall that falls during the summer across Arizona and New Mexico does not occur until after the northern Gulf reaches 28.5 degrees Celsius. You can see right now the average temperature is somewhere in that 23 to 25 degree range, and so we're not quite there yet, but we're warming fast and we're entering the period where those waters across the central and northern Gulf start to warm rapidly. So we are getting close. Okay, so I want to look now at our winter rainfall from last year. And again, what you're looking at is the rankings in terms of precipitation during the December through March period. Again, this is for this previous last winter. Unfortunately, we did not get all those rains we were hoping to see from our El Nino conditions, and it was actually very dry, below normal and much below normal across the entire desert Southwest, Southern Rockies, and Southern Utah, and even into California. However, you can see in the Pacific Northwest, a lot of rainfall, much above normal conditions, even some record wettest conditions. And the reason I wanted to kind of bring these up as well is, again, according to some of the previous research, some of our wetter monsoon seasons are typically preceded by dry winters, as well as wet winters across the Pacific Northwest. Some of the logic behind that is lower snowpack amounts across the southern Rockies and southern Utah, and soil conditions can help move the monsoon ridge further north faster, again, potentially setting up favorable conditions to see rain in the desert Southwest. So lastly, I wanted to just quickly talk about our wild card every year, which is the hurricane season, the East Pacific Hurricane Outlook. Last year was pretty significant. It was the second most active with 26 named storms, 16 hurricanes, 11 of which were major. That animation behind which you can see is actually of Patricia, which was the strongest hurricane in the Western Hemisphere that we've ever seen, and it was also the strongest landfalling hurricane in the Eastern Pacific. So pretty impressive storm in October there. But as far as for 2016, the Hurricane Center is expecting more of a normal season, so something along the lines of 13 to 20 named storms, 6 to 11 hurricanes, 3 of 6 expected to be major hurricanes. I just wanted to point out that, again, it only takes one, or it even takes the assistance of one. The actual remnants don't have to move into the desert Southwest, but if we have the right ridge placement, we can pull that moisture north, and it can aid in thunderstorm development and subsequent rainfall. So kind of pulling this all together here, NOAA CPC forecast is expecting above normal temperatures, equal chances for above or below normal precipitation. As usual, it's always a complex forecast. It's almost like throwing darts at a dartboard. But reason for optimism would be some of these larger scale predictive factors in regards to the monsoon ridge and its placement. It looks like there's, a good shot at we could see a normal to possibly even a wet monsoon if we go on those alone. I want to emphasize again, it only takes a few heavy rain events to reach our monsoon rainfall quota at the airport or overall as a whole across the county, especially if we see any widespread significant events like we saw in 2014 or perhaps like what we saw in Wickenburg last year during July. And it's also important to note that, again, any location in the Phoenix Valley or the urban corridor is subject to flooding or flash flooding if enough rain falls in the right amount of the period. So now is the time really to prepare, and we've got all sorts of information available through the Flood Control District, as well as the National Weather Service, and you'll see plenty of information on the local news broadcasts. I'll move on to questions at this point, and I'm also going to just leave this slide up here that just shows how you get to some more of our information. But any questions, I'd be happy to take them now.